Um, আজকে আমরা হচ্ছে today we are going to study some of the properties that we were actually learning. So continuing with that, today we will learn some topics. We will learn about slopes, maxima, and minima. Okay. So in the previous class, we were seeing a graph of a car that was moving. So with the continuation of that, let me just suppose uh, uh, time and the distance is given. So it is suppose we have t second, basically distance with respect to time. So this is our distance. And so for 19 second, this is 200 meter, and for 20 second, suppose it's also 200 meter. So anything can be happen, like maybe the car uh went somewhere and then it returned again. But let's just assume that the car didn't move. So let's draw a graph. Suppose this is our graph. Hmm, this is our graph, and this is the distance x. This is distance, and we had that. Suppose this is our 200 meter, and somewhere we have the um suppose this is our this is t time. So suppose this is 19 second and this is 20 second. So basically this will be 19 comma 200, and this will be 20 comma 200. Okay, so I'll just draw the line here in and um so here the slope will be 0. Its slope will be 0 because the tangent line because the tangent lines uh, okay, so its slope is 0, and if we calculate slope is equals to del x by del t, to be 20 minus 20, sorry, 200 minus 200, and 20 minus 90. So it will be 0 by 1. So we are seeing that there is no rise. There is no rise in x. So there is no rise in x here. And moving on, let's talk about maxima and minima. Okay. So suppose imagine we have that car, and that car is somehow like it is moving. So suppose it's going upward, and then it's moving downward, and then again upward, downward, and like it's moving and moving. So here, uh, if I wanna draw tangent line, so these are the tangent point. This, 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 and this. So basically, um, it all had the horizontal line here, and basically horizontal line hole the tangent, and basically the slope will be zero. Slope will be zero. So therefore, in these points, the velocity will be zero, which means the car stopped at these points. So, in this given trajectory, where was the velocity of car was zero. So basically, so let me write something. In given trajectory, where does v of car was zero. So this will be in the tangent points. uh, so since this is the highest point, and since we had seen that in the tangent points, the horizontal line, so that is our slope, and therefore the slope is zero. So obviously in these points the velocity will be zero. And we have another question, like at what time was the car farthest from its starting point? So we can see something that this is the most highest point. So this is the farthest from the starting point, and the highest point plus slope will be basically 0 plus v, so 0. So basically the car is not moving. Okay. So we will get the maximum and minimum where our slope is 0 or the tangent line is horizontal. So let me write that. Okay. So we'll get the maximum and minimum where the slope will be 0, or the tangent line is horizontal, or the tangent line is horizontal. Okay, um, okay, so now we will look into uh, derivative notation. We will see. So, derivatives can be expressed in two ways, and one of them are Leibniz, and another one is Lagrange's. So, let's talk about Leibniz notation. So, suppose we have a graph like this, and this is something like that. Suppose we have a point here. Uh, let's draw a tangent line here. Suppose this is our tangent line. So, so this is our, suppose this is our dx, and this is our dy. So previously we learned that slope is basically change in distance by change in time. So slope will be basically del x by del t. So basically at first we take a very long interval to determine the slope, like uh, basically something like this. Um, and suppose we have, let's draw a thin line here. Suppose something like this. So sorry, let's take yellow. So this and this, so let's add this. So this will be our del t, and this will be the del x. Then if we keep uh, lessening the interval gradually, we will get the like something like this, something like this, something like this, like very tiny. So we will get the tangent line, and basically this one, and this slope will be called, so the tiny portion of the slope will be dx by dt. Okay, so basically dx by dt represents infinitesimal change in x direction and the t direction. So in general, x is our horizontal axis, horizontal axis, and y is vertical axis. So now uh, we write we can write dx by dy. Now let's say if we have a function, suppose we have a function f of x and that is y. So this function or the this function's derivative can be expressed in two ways. One of them is f prime x, which is um, which is Lagrange's notation, and um, another one is dy by ddx of y. So ddx of f of x. So this is called Leibniz notation. Okay. Okay. So next we are going to talk about um, we're going to talk about some common derivatives. So starting off, let's start with lines. So basically, calculating derivative of uh, most functions we know, such as constant function, linear function, quadratics, polynomial, exponential, logarithmic, etc. We will see afterwards. So let's start with um, derivative of a constant. So let me draw a graph. So let's start with a line, a horizontal line. So suppose this is our line here, and suppose we have this is our x naught and this is our x. So this is let's draw at first. So let's draw a tangent line. So this will be our tangent line, and this tangent line has some slope as the entire line basically, and this is our height. This is our height. So the function will be y is equals to f of x is equals to c. So this is our constant. And so the slope will be del y by del x. So the change in the y, the change in the y is always 0 because y is equal to c. So it's basically c minus c and x1 minus x naught. So it will be 0. So f of x, f prime of x is equal to 0. So basically from this we can come to a conclusion that a let me write here, a horizontal line or a constant always has the derivatives of 0. So basically কনস্ট্যান্টের ডেরিভেটিভ অ্যাকচুয়ালি 0 হয়, সেটাই আমরা এখন মানে এতক্ষণ দেখলাম। And next we're gonna see suppose we have a generic line. So that is, suppose we have, let's draw a graph. Sorry, it's not straight. Uh, okay. So, so this is a graph, and suppose we have a line here, and so the equation is f of x is equals to ax plus b. So this a is basically slope, and this b is y-intercept. Okay, so here this is the del y and this will be del x. Previously we have seen. So as we have read before, so del y by del x is equal to that we learned before, rise over run. So it will be a. So we are getting a, which is slope. So when it's like very small, I mean like we have seen before, as in like this like very tiny. So জিনিসগুলোকে ছোট করতে করতে when we suppose we are reaching at a point like this, so basically okay, so basically এটাই আর কি। Then so when it's like very small, the tangent stays on the same slope, and same slope for some reason, as what happened with the constant line. So this will be f of prime x is equals to a. So if we want to see it in a mathematical form, it will be like something like this. So suppose we have a point here, and this and this. So this will be x comma ax plus b, and this point will be x plus del x comma a of x plus del x plus b. So basically we had the equation here, like sorry, f of x equal to ax plus b, right? So this x, in this x, this is now our x plus del x. So basically we are putting that into here like x, and we finally got a x plus del x plus b, a point. So now moving on, now okay, so slope will be, as we have seen before, del y by del x. So it's x plus del x plus b minus ax plus b. Basically x1 minus x naught, that we have previously seen, and নিচে হবে হচ্ছে del x. So it's del এটা এটা তো কাটাকাটি যাবে, এটা যাবে. So basically we will have del x by del x of a, and so it will be a. So therefore we can conclude that d dx of f is basically f prime of x, which is a. Okay, next. Okay, so let us now talk about derivative of quadratic function. So derivative. So let's take a very simple one, which is parabola, like this. So this side, this side is basically the positive side, sorry, the positive side, and this is our negative side, and this is y, and this is basically x. Okay, so suppose we have a point here, that is suppose we have 1 comma 1. So basically the equation is y is equal to f of x is equals to x square, and so basically the slope will be like we have seen before, it's del f by del x. So the del f is basically, change in y, let's change it y. Okay, so let's write it a bit. So it's x plus del x whole square minus x square, and the del x will be 0. So let's look at some sequence. Calculating slope with that will calculate slope of tangent line. So let me draw a okay. So suppose we have del x here and we have del f, and here we'll calculate slope. Okay, so suppose we have del x, suppose del x is 1, the interval of length 1 horizontally. Let me show you like something like this. Suppose we have this line and it goes like this, and we have a point here 1 comma 1. So basically suppose we have a point here 2 comma 4. So this is like interval of length 1 horizontally. So this is our del x, which is I have calculated, suppose it's 1, and um, this this is our del f, this one. Okay, so if we calculate the del f, this will be as we have seen before, this equation. So it will be something like 1 plus 1 whole square minus 1 square, basically this. So it comes 4 minus 1 is equals to 3. So del f will be 3 here. So del f will be 3 here, and the slope will be del f by del x, so is equal to 3 by 1, so it's 3. So our slope is 3 here. So next, if we make it half, like suppose we have here 1.5 and we have um, okay, so we have 2.25. So this will be something like this. Okay, so we will calculate it like in this way. So it will be 1.5. Wait, let me calculate this. 1.5 plus 1. Okay, so basically our del x is half, so del f will be 1.25, and if we calculate the slope, this is 1.25 by 0.5, so which is 2.5. basically this. Sorry, not this. So basically this is the slope, I mean. So the slope will be 2.5 here. And now if we take the, for suppose 1000, 1 by 1000, so it will be like 0.002 and this will be 2.001. So the derivation will be f of suppose 1, so it will be ddx of f of 1, so it's 2. So slope of the tangent at 1 is 2. And now let's calculate the formula. So it was something like del f by del x. So f of x plus del x minus f of x, and so it's del x, so it will be x plus del x whole square minus x square. So it's del x, and then let's calculate this x square plus 2x del x. I'm putting it into formula, plus del x whole square minus x square by del x. So after calculating, it will come as 2x plus del x. So now this del x, is tends to 0, as we had seen before, like it turns into something a point, like choto hote hote. So we can count it as 2x. So therefore ddx of x square will be 2x. Okay. Okay, so today we have learned slopes, maxima, minima, and we have also seen derivative notation like Leibniz and um, Lagrange notation. And then we have seen some common derivatives of, as in we have seen derivatives of constant. We also have seen of a generic line and also a quadratic function. So in the next class, we will see more. So till then, stay tuned.